Okay, let me make sure my audio is working. Okay, let me make sure my audio is working. Okay, and let's go. Sandwich in a Cyclone by ZegreS. And it's one of those ones that just has only a couple rules, just standard arrow rules and standard sandwich rules. And I usually like these because it's not trying to trick you with anything, you know, just really complicated, but there's usually some nice logic in these. Okay, so these are a couple really long arrows here, and let's see if we can restrict these. So these digits here need to be, so this one gets counted, let's just color these in. So these ones, these two get counted for both of these, and that's going to equal 2 times this. So we have 6, 12, 13, 14, yeah, plus, wait, I already counted this one. So I didn't count this one, so it seems like we have 1 degree of freedom. Let me just double check that. These are minimum of 7 if this is 1, 2, 3 and the 1 is the double counted. 7 plus the 3. Is there some other way I could count these that would give me a higher count? 3, 3. So 7 plus 6, 13, 14, 15, 16, 17. Well, this has to be a 1, because otherwise that's going to take away my degree of freedom. There's 1 degree of freedom in these, so these need a 1. 1 degree of freedom here. And then if the 2 gets doubled, I think the 1 has to be the double counted one, because if it's 1, 2, 3 with the 2 double counted, that'd be 8. So I guess we could have a 2 double counted if it's 1, 2, 3. But then it could be a 4 with the 1 double counted. Okay. Oh well, the 1 is looking at this, and the 1's looking at that. And 1's looking here and here. So this could have to be a 1, because otherwise, if we had a 2 double counted without a 1, that would just be way too big. Okay, so I still have 1 degree of freedom in here. But now I have some 1s that I can use for this 15 clue and for this 14 clue. I guess I could pencil mark. This arrow's pretty long too. Is it worth thinking about? Obviously I can't put a 1 in the arrow. So minimums 2, 1, 1, 3. 2, 1, 1, 3. So that's a minimum of 7. Okay. Maybe it's time to look at the sandwich stuff. So 14 in a sum, 2, 3, 4, 5 is 14. So I could have 4 cells in it. So it's a possibility of 4 cells, but it could also be as small as 2 cells if it's a 6, 8. Well, it would have to be exactly a 6, 8 to be a 2 cell. Okay, so these are the only possibilities, right? Because it's either the 9 has to be in one of these 2 cells in this direction, and then 15 can also be 2 cells, and it could also be a maximum of 5 cells. So I think we have a 9 in here. Now, I don't think we can put them both here, because then we might have to end up with some big numbers in here. That's some... Because 14, if a 9 goes here, this has to be exactly 2, 3, 4, 5. And if it's a 9 here, it needs to be 2, 3, 4, 6. Actually, this seems possible. Yeah, and then 7, 8, 9 go here. I don't see anything particularly wrong with this. We remove 9 from here. Yeah, I don't know. But if I put a 9 here, that's gonna put a lot. Ooh, hold up. That might have to be that case, because if I put the 9 here, this has to be 6, 8, and now there's a pretty large digit here. Oh no, but the 6, maybe 9, because the 6 could go part of this longer one, 2, 3, 4, 6. But if I put the 9 here, then there's no way, right? There's no way that this works out, because this is just too big, and then the 9 would need to go here. So I can eliminate the 9 here. We can put 9 here. 15 in 4 digits has to be 2, 3, 4, 6. I guess we can pencil mark 5, 7, 8 out here. But this does leave the option of 9 here with a 6, 8. And it also leaves the option of 9 here with a 2, 3, 4, 5. But I can't put like a 7 or 8 here, because if I put a 7, I can't put a 6, 7, or 8 in this square, because that would force 9 here, but with digits that can't go in a 4 cell sum, sandwich sum. So 7 and 8 are in these two squares, in these two of these three squares. Okay, so what did that teach me? Well, I know 1 goes here, but not there. And I know 1 goes here, but not there. And I'm assuming that's important, that the 1 cannot go anywhere in these cells. So 8 and 18 sum needs to be at least 3 cells. And is a maximum of 4 cells as well? Because 4 cell maximum is 14, and then if I were to add another cell, it would have to be a 6 to make 20. So 18 has to be either 3 or 4 cells, so that's pretty limited. Okay. What does that tell me? So for example, if the 1 were to go anywhere here, like let's say the 1 were to go here, 9 would have to go here. I guess that would work. But I don't think I can put 1 here, because this would be... No, I guess that would be fine. 4 cells. I can't put a 1 here, but what does that mean? Because I can't reach a 9. Oh, and clearly this has to be a 9, given that I have 1 degree of freedom. Let's not forget that. Actually, does that 9 help? Not really. This is at least a 5. 9 in this box. I'm not sure what any of this does. Did I miscount something here? Can I not put 2 in both of these or something? Oh, well, this is a 2, 3, 4, 6. This digit's the same as this digit because it's part of a... Okay, so if I mark these digits as the same, do I have to think about this arrow? I haven't thought about that arrow in a minute. This could still even be that cell. If I put a 1 not here, then I would need to span these digits. There has to be a 1 in one of these two, which means that either this is part of the sandwich or this is part of that sandwich. Oh boy, I actually need to pause this for a second and be right back. Okay, so I was just thinking about one of these needs to be a 1. Therefore, either this is part of this sandwich or this is part of this sandwich. And while I was AFK a second, I also thought about these two arrows combined, but I didn't really think about the arrows as individual quantities. So here I only have 3, so these need to add up to 6. Can I prove that this is like a pair or something and that is my degree of freedom? Maybe it's the case that these are both 1s and these both need to be part of the sandwiches. Let's think a second. Well, wait, if I put it... It's easier than that. If I put a 2 here, I put a 3 there, and then that's used up 2 degrees of freedom. So these have to be 1s, because, yeah, that doesn't work. Okay, so we do in fact know that this needs to be part of the 18 sandwich. And this needs to be part of this 14 sandwich. Let me just see what else this did. So 1, 2, 3, So these need to add up to 5, and therefore these do need to be a 2-3 pair. Yeah. Then these need to add up to 5, and therefore must also be a 2-3 pair. So now I know that this digit is also blue, and then let's mark this other 2-3. So that's my degree of freedom used up, given that there's at least a 3 in one of these two squares. Do I now need to think about this? Because now minimum 2, 2, 2, 3 is a, yeah, that's a 9. 2, 2, 2, 3, and we know that this is the purple and this is the blue 2, 3. Okay, oh, that makes purple 3. That makes blue 2. 2. I can just get rid of this. I'll just leave the coloring, whatever. 2 has to go here. 2 can't be in that bulb. 2 goes here. I think I have all my 2's in. Okay, and then 1's are decided. And, oh, I see. So now where is the 1 in this column? It has to be here. And then the 14, 9 will have to be here, making this a 2, 3, 4, 5. Making this 6, 7, 8, and then therefore this must be 8 and 6, 7. 1 here is going to place a 9 there. Okay, 9's here. Oh, since 9's not there, it had to be here. With the 6, 8 for the 14. This is a 4. These are 5, 7, and 8. Now this 18. We can't use any more 2's. 4, 5, 12. No, it can't be a 4, 5. But if it was 4, 5, I would need a 6. Which means that this is going to have to be a 5, right? Because there's no way I can fit a 7 in there. Okay, so I got 8 plus 10, which would have to be 4, 6 at this point. Okay, so now I have 7 here, and I have 8 here. Okay. I'm sure once my brain starts working, this probably opened up a lot of Sudoku that can be done. 7 here. There's one of these two. I know 9 goes here. Is that all my 9's in? It should be. This isn't 4. We know 8 is in here, therefore not there. I guess the only piece of information I haven't used is this arrow. Can't be a 3, can't be a 4. Could be a 5. Could be a 6. Can't be a 7. Could be an 8. Is there some... No, I used this sandwich. I used all the sandwiches. It's just got to be Sudoku. I'm just being slow. Just being slow. But what is in particular? I got my ones, I got my twos. I don't have, oh, there's a 3 in here. And a 3 in here. No, a 3 is going to be a 3 as well. What am I missing? It's always frustrating when you do the logic well and then the Sudoku trips you up. Oh boy. Is there some kind of like weak cells that has a lot of things pointing at it? 4, 6, this is the same digit goes here. Because what other restrictions do I even have? Don't have many 4s, only a couple 5s, only a couple 6s. Well, 7 goes in here and in here, therefore here. 8s. Oh, there's... Okay, 3, 4, 5. I need a 6 in here as well as another one more 3, 4, 5. That 8 really didn't do all that much. Well, there has to be a 6. Oh, there has to be a 6 here, therefore 6 here. 6 in one of these two, and 6 in one of these two puts a 6 here. So the other 3, 4, 5 is in here with 7, so we have one more 3, 4, 5 in here. So it's going to be something to do with these 3, 4, 5s, but I have a 6 and an 8 in here, therefore only one 3, 4, 5. So this is also a 3, 4, 5 in here. Oh, 9's just placeable here. Oh boy. This is not a 5. Did that placeable 9 do anything to me? There's a 7 in one of these two. There's 2 of 3, 4, 5 in here. This is a oh, this 6 here is going to force a 6 into here. Oh, or more easily, the 4, the 6 there, looking right at there. Okay. That's going to force a 6 there. We got an 8 somewhere in here, an 8 to 4 or 5. 4's not there. This is a 3, 4, 5. Oh, this is just a 3, 4, making this not an 8. These are 3, 4, 5. Three, 5, 4. 4, 6, 6, 6. Oh, there's a 6 looking right at this too. And the 3 must go here. So we got a 7 in here. That's not in, oops, not in here. 7, this is 4, 5, 6. Not a 5. 4, 5, 7. Threes in one of these 2 squares. Okay, I'm missing something obvious again. There's another 4, 5 in here. Let's put it with the 7. 4, 5. Oh, 7's not there. So this is a 3, 4, 5 as well. And this is the only place a 6 can go in that column. This isn't the 3. 4, 5, 7 in here. 4, 7. Wait, something's wrong. No. I got wrong pencil marks here. Let's. Jeez. Okay. That was almost like the worst. Just for some reason I do that. I just start going on autopilot or something, and just my almost make really silly mistakes like that. This is a 4, 7. This is 3, 4, 5, 7. Anything. Okay, so if this were to be the 6, 8, we need to put, okay, so that still was true, that 6 has to be here in that column. This is not a 7. This, I almost marked this, see, I almost did that again. I almost marked this as a 3, 4, because I'm like, oh, 3, 4, but it's because this 4 was looking at this, and I hadn't resolved that. I thought, oh, I can't resolve this, so I must still need the 4 as well. Something like that. Something like that. Seven, 6, 3, 4, 6, 8, 4, 5, 3, 4, 7, 5, 4, 7, 4, 5, 8. Okay, and that's puzzle done. So, despite my best efforts, I did manage to complete that. And I'm going to take a short break, but I'll probably do one more puzzle.